Alright, in this video we're going to talk about segments, rays, and distance. So really what we're kind of thinking about is the kind of lines piece of the three undefined terms: point, lines, planes. So we're going to focus today on lines. Okay. So a couple things to think about. First of all, a line, in the truest sense of the word, extends infinitely in both directions. So if I have this little piece here, and if I pick a point A and B on it, then in theory this line is really one-dimensional and never ends. So it kind of shoots out in both directions forever and ever and ever. And I can write that either as line AB or BA. It doesn't really matter. Order doesn't matter. Any 2 points on that line. Sometimes we'll get a little lazy and I'll put an L in there and we'll call it line L. Okay. Now that's a little bit different from a segment, and a segment is just a piece of that. So a segment has a length. It's finite in length. And so instead of continuing on and on forever and ever, a segment has one endpoint and another endpoint. So we'll call that CD. And again, the way that I write that is CD or BC. Order doesn't matter. Now the neat thing about these segments is that they have lengths, right? Because they are finite. So if I can measure that or quantify those 2 points in one way or another, I can find the length of that finite segment. And of course the ray, like a drop of golden sun, a ray is, oh, I don't like that color. A ray looks like this, and so a ray has one endpoint and then extends infinitely in a direction, one direction. So I'm going to put a P there, and I'm going to put a Q there, and so we'll call that ray PQ. Okay, and not ray QP. This piece right here, that P is the endpoint of the ray. That's where it starts. Okay, so that's just a little notation, some things to consider. There's a neat little idea if we go back to these segments. I'm going to talk about segments for a little bit. And let's start a new page here. So these segments, they behave pretty nicely. Okay, and one thing is, of course, they're straight, but they have distance, a length. And if we can find the length, then we can find the midpoints, which we'll talk about. And we can kind of manipulate these guys, and here's an example. So let's suppose we have a segment, and I'll just make it nice and crazy there. So call that A and B, and what I'm going to do is I'm going to put a point on AB. So if I put that little C there, that point C is between points A and B. Okay. And what that implies, whoopsie daisy, they're my kids. What that implies is that the 3 points are collinear. Okay. So in any event, there are really 3 lengths we could consider here. This little length right here is AC. This little length right here is CB. And then of course we have the length of the whole segment, AB. And so as long as C is between points A and B, then what we know is that the length from A to C, which I write as that, plus the length from C to B is equal to the whole. Right? Piece plus piece equals whole. Right? Or AC, and here's AC, whoops. AC is a yellow length, right? The distance from A to C, plus CB, the distance from C to B, is equal to the whole AB. And that's pretty obvious, and things that are in geometry pretty obvious, trivial, are called postulates. And so this guy is called the segment addition postulate. Right? Piece plus piece is whole. Pretty obvious, but again, postulates are unproven truths, obvious truths. Let me build from there. So let's look at a numerical example, and let's say that, well, I'm going to give you a little segment here, and let's quantify this. So let's say that we'll call that A and B here, and we'll put C there. And let's say AB is X, and BC, let's say, can be 3X plus 6. And let's say AC, the whole, is, I don't know, 24. Okay? So if I ask you to solve for X, what we're going to use is the segment addition postulate. So the distance from A to B is X. I'm going to put that here. From B to C is 3X plus 6. And I also know the whole AC is 24. So by the segment addition postulate, I can say X, which is AB, plus 3X plus 6, which is BC, is equal to the whole, which is 24. Alright, so piece plus other piece equals the whole. And then, of course, we can solve for X, so 4X's plus 6 is 24. And then if I subtract 6, I get, and then if I divide by 4, I get 18/4, which is the same thing as 4.5. Okay. Or we can look at another problem. And again, that's brought to you by segment addition postulate. What if we had this, a number line, all right, and I give you some numbers, so 1, 2, 3, 4, -1, -2, -3, etc., etc. And so let's pick 2 points. Let's say here's 1 and here's another, and we'll call this first point P and Q. So how long is PQ? What's the midpoint of PQ? And that's segment PQ. Well, one way I can do is just counting, right? The segment PQ is, that's 1 unit, that's 2, that's 3, that's 4. Okay? But that's not always the best way to do it. Another way is to think about distance, and the distance between P and Q is just the absolute value of the difference of the two numbers. So it's -3 minus 1, right? Here's my -3, and here's my 1. So to find the distance between two numbers, you just take the difference means we're subtracting, of the two numbers, and since its distance is positive, we're going to take the absolute value. So the way I work that is -3 minus 1 inside is -4. Take the absolute value of that to get 4. Right, so it's 4 units to get from -3 to 1, from point P to point Q. So what's a midpoint? Well, since we know it's 4 units long, right, the midpoint is going to be halfway between. So technically, a midpoint creates 2 congruent segments. But it has to be, of course, the midpoint has to be on that line between points P and Q. So if the whole thing is 4, then the midpoint is going to be 2 units from either one. So I'm going to move 1, 2 from Q, or 1, 2 from P. Either way, you wind up at -1, and I'll call that M for midpoint. So M is, midpoint is at -1. Okay. Finally, let's think about this idea of midpoint. And here's a neat, interesting thing about geometry. If M is a midpoint of AB, a segment, right, then AM equals MB. Right, so that seems like it might be true. But what I can have is a point here A and a point here B, and I can go up and up. And if that's 10 and that's 10, well, here it satisfies this piece right here. Right, they're both 10, but M ain't the midpoint of AB because M's not even on AB. So another thing we have to add to that is that M is between A and B. And between, remember, implies that they're all on the same line. Alright, so now M's got to be on the segment and between. Okay, so here is the correct midpoint. Alright, so I threw a lot at you, some basic things, some new notation. I do have a couple things for you to consider for your homework assignment. So here, a little bit different version. So here's a point A and B on a number line, and I want you to find AB. Remember, that means the distance of segment AB, and then the midpoint of segment AB. Okay, on this particular problem, we have 2 dimensions, so this is called a Cartesian plane. So what I want you to do here is find PQ, and that's the distance from this point P and that point Q, and then find the midpoint of that segment PQ. Now this guy's a little trickier, and if you have to go Google the distance formula or midpoint formula, then do so. Alright, good luck trying these. Have fun. Thanks for listening. We'll see you tomorrow.